We're moving now into the Entropy and Spontaneity lab for sodium bicarbonate. So we have a coffee cup calorimeter set up here, and we're going to go ahead and turn on our thermometer. We're then going to add 100 milliliters of pure distilled water to our calorimeter and record the initial temperature here, because we're going to need to do a temperature change. This should be about room temperature because the water's been sitting out for a while. 23.1 degrees, as you can see here. So that's our initial temperature. We'll then get the sodium bicarbonate and add it to our water. So for this lab, we're going to need 10.00 grams of the sodium bicarbonate, baking soda here. So we're going to go ahead and measure this out using our zeroed out scale. As you can see here, we got our 10 grams of the sodium bicarbonate. It seems to be fluctuating a little bit here, but that's about 10 grams. So we can go ahead and take this and move it to the coffee cup calorimeter. As you can see here, we have our calorimeter and a magnet currently inside of it spinning. We're going to be adding our sodium bicarbonate to it and recording and watching carefully to see if we can spot the lowest temperature that is going to get down to. So we can go ahead and add this now, and we're going to quickly cover it with that lid once we add it. So we'll go our 10 grams there. Let's stick this back in and watch the temperature. The lowest temperature reading we seem to have here is about 18.6. If it gets, it's not going to get anywhere drastically lower than that, so this can be recorded as the lowest temperature here of our sodium bicarbonate mixture with the water. Remember that it changed from about 23.1 degrees Celsius now down to 18.6. You'll later be using this in a spontaneity calculation. The next thing that we need to do is we need to rinse and fill this burette with some 0.2 molar hydrochloric acid. So we gotta make sure that it's closed down here at the bottom. So you should be able to go ahead and put some of the acid into there in order to rinse it. And we could pour some of the acid out through the top like that in order to rinse it. Spin it while you're doing that. And additionally, I open the bottom of your burette here so that you know the acid is going through the tip of the burette as well. And that's how to rinse the burette with hydrochloric acid. After rinsing the burette the second time, I ended up filling it almost all the way, so with about 50 milliliters of the hydrochloric acid, the 2 molar hydrochloric acid. The next step is we're going to take a 125 milliliter Erlenmeyer beaker like this, and we can put our stirring magnet in there, and we're going to be adding 25 milliliters of the sodium bicarbonate mixture. Using one of these pipettes is just the best way to do it. You want to make sure that none of the solid enters that pipette, so just go carefully. We're going to be putting this into our beaker. So there's our 25 milliliters. We can go ahead and put this into the flask. And we're going to be adding a few drops of this brome cresol green indicator. So you can see here, the indicator has made the solution pretty blue in color, like this. And that is good. That's what you would like to see. We're going to go ahead and put this on our spinning plate. So we can turn on the plate here so that it's spinning. And then we're going to be adding some of the acid until it's titrated. You'll know that this is titrated when the indicator changes from a bluish color to a yellowish color. So the initial reading on the burette is about 1.60 milliliters, and we're going to go ahead and add some of this until we get to that yellowish color. I'm going to go ahead and let that mix for a little bit here, and we can go ahead and add some more. Okay, there you go. Hopefully you can see how this is a yellow color, and the yellow seems to be there to stay rather than just being temporary. As we mix it, it stays yellow. The final reading on the burette is 15.03 milliliters or so. So the difference between that and the 1.60 milliliters is going to be the amount of the acid that we had to use this time in order to titrate it. That should be 13.43 milliliters in total. We're then going to repeat that procedure 2 more times, since we have the time in order to do that. First getting the 25 milliliters into our pipette. And then taking these milliliters and putting them into our flask. Adding some of the drops of the brome creosote green indicator. And titrating until we get to a yellowish color. This time we're beginning at that 15.03 milliliters that we ended off on last time. And I'll let that sit for just a second. Make sure that it's mixed in there all of the way. And keep going until we get that yellowish color to stay. There you go, the second time around. The yellow color seems to be staying for us. So now the final reading is at about 28.34 milliliters. So the difference between 28.34 and that 15.03 we started off at is going to be the amount of hydrochloric acid it took this time in order to titrate our solution. This time the number of milliliters seems to be 13.31 according to my calculations that I saw, and we're going to go ahead and do this again. Trial number 3. $25 milliliters into flask. A few drops of brome creosote green. And now we need to titrate it. Currently at about 28.34 milliliters. So we're going to go ahead and add some until we get that yellowish color. That's pretty much on the lines. We're going to go add a little bit more of the acid, like that. And now the color should persist. We ended off here at about 42.06 milliliters. So in total, this third trial took 13.72 milliliters of the 2 molar hydrochloric acid to titrate our sodium bicarbonate. You're then going to need to find an average of those three values, 13.31, 13.43, and 13.72, in order to find an average volume of 2 molar hydrochloric acid that it took to titrate our sodium bicarbonate. Once you have collected all of your data, there are a few calculations that you'll need to make. First, you'll need to determine the titrated volume of HCl for each trial. Kind of did that for you already, but then you're going to need to find the average titrated volume of the hydrochloric acid. This will tell you how many moles of the sodium bicarbonate dissolved, which will in turn tell you the sodium plus concentration. Then we're going to do that temperature change. Remember that at the beginning of this lab. And this data will help you determine delta H for this lab of the dissolving of the sodium bicarbonate. And the concentration from here in the first part of the data processing and analysis will actually help you to determine the value of K for dissolving sodium bicarbonate. Remember, all of this is stuff that we have learned so far throughout AP Chemistry. And then we're going to be using all of the numbers that we've calculated, the change in temperature, the mass of the water, the temperature in Kelvin, which is the room temperature, 23.1 degrees Celsius or so, the value of K that you calculate. All of these numbers are going to be things that we can calculate using what we have previously known about chemistry.